and you don't have these calculators, please make sure your Chromebook or your phone is in degree mode, because usually they go right to radian mode, and you're doing all these problems and you're wondering why the heck you're getting every single one wrong. It's not probably because you're not in degree mode. All right. All right. First one up, using sine. We got to review how to do sine, cosine, tangent. There's going to be probably more than one question using sine, cosine, tangent. It's multiple choice, and probably you'll see it on parts 2 and 3. All right, we said yesterday part 4 is probably the proof, but parts 2 and 3 definitely you might see a sine, cosine, tangent question. So let's review. Find side x for me. Find side x. Now everyone notices this is 30, and I know most of you are pretty clever here, so you're like, oh, this is a 30, 60, 90. Those rules, you do not need to memorize them. They're not required for the exam, because you can use sine, cosine, tangent to figure out these problems. Now, can you still use the rules? Yeah, you can. But I'm just saying, the less is better here. All right, because you guys have a ton of information you got to bring with you up in your minds about what all this geometry course has been about. One less thing isn't that bad. Okay, so no, you do not need to know your 45, 45, 30, 60, because you can get away with using sine, cosine, tangent on these problems. So let's figure out which ratio we need here. We go from the 30 degrees. First thing I need to know from somebody is what's that x and what's the 24? What's the x and what's the 24 up here? Here we go. Let's start with 1, 3. Ayaz, what's the x? Opposite, hypotenuse, adjacent. Adjacent, how about the 24? Hypotenuse. So with the adjacent hypotenuse side, I can use which one of these 3 ratios? Ava? Cosine. Good. So I start cosine, COS, abbreviation, of 30. Put the degree with it, equals the adjacent side x over the hypotenuse 24. And I always had you guys solve this by making proportion out of it, by putting this over 1 and then cross multiply. And that is why your calculator must be in degree mode, because you are now typing in 30 degrees. And after you cross multiply and round to the correctly, if you looked at the rounding directions, after we round Sophia over there 4, what do we have here? X equals 21. There you go. Boom. Quick review on how to find a side. Now a quick review on how do I find an angle. All right, slightly different here at the end of the problem, if you remember. So we're finding angle A. All right, tell me what the 9 and 24 are. I'm not going to start. You start the same way. Tell me what the 9 and the 24 are. Opposite, adjacent, hypotenuse. Where are we going there? Ruby, how about the 9 first? Perfect. And how about the 14? Great work. So it looks like we're going to use cosine again. Set it up the same way we did in problem 1. Cosine, you can put an x there because we're looking for it. I'm going to put A because it's angle A we're looking for. Equals adjacent side 9 over 14. And now it becomes different than finding a side, because I cannot put this over 1 and cross multiply. I'm not going to get anywhere. All right, I'm not going to get anywhere if you try to cross multiply. Instead, here's what we got to remember. If I am asked to find an angle and I'm using sine, cosine, tangent on my calculator, I now need to use A cosine, A tangent, A sine. Okay, we call those are arc, cosine, arc, sine, arc, tangent. You get there by using the shift button. That's what I need to do when I'm asked to find an angle. So now in this case, it's cosine. So angle A is going to be equal to arc cosine, shift on your calculator, shift cosine, and then it's going to give you a parenthesis. You plug in the ratio. You are asking the calculator what angle has a cosine ratio of 9/14. That's what you're asking right now. You're typing into the calculator, hey, calculator, can you tell me what angle has a cosine ratio of 9/14? So please remember, when finding an angle, you need to hit your shift button with arc, sine, cosine, or tangent. And rounding to the nearest degree, what do I have there for angle A? Boom, Ava, back to you again. 50 degrees, thank you. Perfect. Anybody, questions, comments, any concerns? All right, so that's just a quick review. You guys are going to be doing problems later on when I give you enough time that are a little bit more involved that use sine, cosine, tangent, but I just wanted to show you the basics because that's all we have time for. All right, I can't go, remember we did a whole unit on this. All right, I can do it in 5 minutes. That's about it. Something else with sine, cosine, tangent to be aware of, because they will ask, I think, one problem on these, is when are the ratios equal, sine and cosine? When are the sine and the cosine ratios equal to each other? So when is the sine ratio equal to the cosine ratio? When am I allowed to set those two ratios equal to each other? There is only one instance when I can do this. And that is if and only if the angles attached to them. Anybody remember? Not there yet. You're on the right track. Not 180 though.
Complementary.
Complementary. They add to 90. Must add to 90 degrees. I try to do this I don't think I explain it well every year, but here we go. If the angles add to 90, the ratios are equal. If the angles add to 90, the sine and cosine ratios are equal. When are the sine and cosine ratios equal? If the angles add to 90. Quick problem here on number 3. Cosine of 72 equals the sine of what angle? Again, notice, cosine and the sine ratios are equal to each other. That only happens if my angles add to 90 degrees. That only is, if you're going to set sine and cosine ever equal to each other, those angles better equal 90. And what are we getting here? Angle X must be, Ruby? 18, yep. So 90. You have 3 hours to take this exam. Okay, if you're satisfied, you can leave after 2, but we'll talk about that, if that's appropriate or not for an honors level to leave right at 2 hours. But check yourself. If you're unsure, hey, type in cosine 72. You're going to get the decimal / a fraction radical, and then type in sine 18. Should be exact same. Quick check, 2-second check. All right, let's go to 4. Different type of problem, but using the same fact. I got right triangle ABC, so let me just get a little idea of this. Right angle at C. So put my right angle at C. A and B have to be the other 2 vertices. All right, let's slow it down and talk now. Let's see if we really get this fact. The sine of A is 2x plus 0.1, yep. The cosine of B is 4x minus 0.7. What do you know about angle A and B in my diagram? They're not equal. Don't go there. You don't know that. Stop. What do you know about angle A and B? C's 90. That's taken care of. 90 degrees. Out of the way. 90 degrees. Already out of the way. 90 degrees. Already out of the way. What do I know about the other 2 remaining angles there? A and B then. Something about them. Something about them I know. Emily? They add to 90. Everyone agrees? So if they add to 90, what do I know about the ratios? The ratios don't add to 90. The ratios are what? Equal. So everyone looking, I'm giving you the sine ratio and the cosine ratio here. And Emily already told us A and B add to 90. That means those ratios are, what am I going to do with these 2 ratios? Set them equal or add them to 90? The angles add to 90. The ratios are what? Equal. That's why I'm going to set them equal. We got to get that down straight. The angles are the ones that add to 90. A and B add to 90. The sine of A and cosine of B are equal. See the difference? The ratios are equal, but the angles themselves are the ones that add to 90. All right? Don't add these to 90 because now you're saying the ratios add to 90. No, the ratios are equal. And hopefully I drove that point home. And what do you get there when you have x? I just want to make sure you can solve the darn equation. Reagan?
0.4.
Thank you. Questions from you guys? There you go. A little sine cosine tangent review in 6 minutes, even though we spent probably 2.5 weeks on it. That's all we got time for. All right, another big topic. Yeah, we spent a whole unit here, unit 6, quads. What a great unit, huh? What a great unit. So I just provided the chart that has all the properties on it. So you have all the properties in one spot, all the quadrilaterals we went over. Do I expect you to know the properties right now? No, but hey, this is where we're at. We got to know them by June 21st. All right, we got to know them. What's that? 3 weeks from Friday, I believe. 3 weeks from Friday, we got to know them. All right, so, but they are here. So if you need them, it's not an excuse. Go back and look. All right, go back and look. All right, so some Regents type questions here using quadrilaterals, because there's going to be a handful of quadrilateral questions on the Regents. Number 5, parallelogram must be a rectangle when it's what? What's so great about a rectangle, right? What is so great about a rectangle? So a parallelogram becomes a rectangle if, so I'm looking for something special about a rectangle. Yeah, that's why I provided the chart to go back and look. What is so special about a rectangle? Special about a rectangle up here, Eli? Or what? Congruent, correct. Diagonals are congruent. Let me go real quick. Choice 1, that's a rhombus. 3 and 4, that's just a parallel. Those are properties of a rectangle, but it's just a parallelogram though. Okay, what makes it a rectangle is those diagonals being congruent. And hey, I want to prove a point here. That's why I assigned this problem. Is this problem very, very easy? Yeah, and it's also, remember, 2 points. If I don't know my properties, goodbye to those 2 points because I'm just guessing. It's just something as simple as that. All right, these questions. If I know my darn properties, hey, I'm serving you a free 2 points, the Regents exam. Here's free 2 points because you know your properties. But if I don't know my properties, good luck on that one. You're just guessing, right? You're just guessing what it's going to be. I'm sorry I assigned 6 there. It's the same question as 5, just reworded differently. My apologies. All right, a parallelogram is always a rectangle if, the diagonals are congruent. Seven, here we go. Which is the best name for this quadrilateral? Best name for this quad, kids. All right, you know me. I am not it's this one because it looks like it. You better prove to me why it's not the other 3 then. Trapezoid. Anybody remember anything about a trapezoid? Not much. One pair of opposite sides parallel. That's it. Well, it does, but it also has a second pair, doesn't it? So that can't be a trapezoid because trapezoids only have one pair of opposite sides parallel. Rectangle. Even if you don't know every single property of a rectangle, it's all right. What does this not definitely have? Does not have right angles. Well, how do you know that? It doesn't look like it. Don't tell me that. Anybody know how I can tell how A is not a right angle? What I would use? What's up, Ananda?
See if AB and AD are perpendicular.
Yeah, and that would be, we worked on this yesterday. That's why I'm asking. What would you find of AB and AD to show they are not negative reciprocals of each other? Slopes. Okay, so that's how you could show it's not a right angle. So rectangle, thank you. Now I'm down to 2, rhombus and square. Definitely getting rid of, if you got rid of rectangle, what are you getting rid of?
Square.
It's got no right angles. So you're definitely getting rid of square. So yes, it is a rhombus. All right, let's talk. We are going to do this on day 6. How could you show that's a rhombus? Instead of other than process of elimination. Liam, one way.
Distance formula?
Distance to show all 4 sides are congruent. Also, if you look back, diagonals of a rhombus are perpendicular. Look, that is a vertical line. And what's the other diagonal? They're always perpendicular. So there's a quick way of showing that that's got to be a rhombus. Diagonals are perpendicular. When I'm done talking, you and your groups are going to do number 8. All right, you and your groups are going to do number 8 because I need you guys to do something on your own other than me talking. And you're going to do number 9. We're going to do number 10 together right now. We're going to do 10 together. Properties of a parallelogram. Angle R, a buck 24. and side segments AF and FD are congruent. I need your help getting me to angle AFD right now. Get me to angle AFD. Told you it was a parallelogram for a reason, right? Told you it was a parallelogram for a reason. To label more angles. So here's my first question to one of you guys. Give me another angle measure you're confident in. Not the final answer. I do not want the final. Just give me another angle that says label this angle this many degrees and let me know why. 1, 2 here. Jordan, give me another angle you're confident in. Thank you. That's a property of a parallelogram. Opposite angles congruent. Good start, Jordan. Good work. All right, give me another angle you're confident in because I don't think I can go right to the final answer yet. Give me another angle you're confident in. Don't overthink this, Allison.
56.
Which one?
Angle FDA.
Okay, good. 56 right here. That's why I said don't overthink it, right? Linear pairs. It's like day 2 of this course. Linear pairs, supplementary. All right, give me another angle you're confident in. Thank you, Allison. Good job. Allison, again, another one.
Angle FAD 56.
Yep. Now we're doing isosceles triangles. Angles across from the congruent sides are congruent, and now I'll take it from here. I'm hoping everyone can find AFD now. 180 minus the 256s. 68. Questions, comments, any concerns? Looks good. Okay, you're going to do 8 and 9 in a second. In a second, I have one more topic to go over today. Usually you can find one of these questions on every Regents, and that is, how many degrees can you rotate a polygon so you get that same polygon back? Okay, and that's what I'm asking here with the pentagon. What's the minimum number of degrees I can rotate it, carry it onto itself? So everyone sees the pentagon that's staring you in the face up on the board. Not the same one, but the same looking one I want. Same position, same size, everything. Yes, I get it. Hey, I know I could go around 360 and get it back, but I can go less than that, and that's what I'm looking for, the minimum number. So, you ready? What about how many degrees did I just go there? That's what I'm looking for. Minimum. I know I can go 360. I get that, but that's not the minimum amount I can go. All right, well, let's talk, because that 360 will come into play. How many turns would it take for me to go 360? Well, ready? 1 turn, vertice to vertice. 2 turns. 3, and you guys are probably picking this up already. 4, and to get back all the way around, I would do it 5 times. 5 equal degree turns right there. 5 equal degree turns. So I could go 72 degrees. Minimum. And that's what it's asking for. Let me just, because sometimes they don't ask for the minimum. What are other degree measures I could go? I could go 72, add another 72. I could go 144, add another 72, another 72, another 72. All right, any multiple of 72 there would get me back to my original pentagon. So that leads us to number 9. We're going to finish it here. A decagon. Ooh, how many sides there? Decagon? Anybody? Decagon? I'll call on somebody. Decagon. What are we thinking there, Megan? 10, yep. So now we're thinking up 360 divided by 10, and you're correct, but watch what happens now. That's why we got to understand the difference in these problems. I get 36. Oh my God, that's not an answer. Something must be wrong. Trick question. No. 36 is the minimum amount. Every time you go another 36, you're going to get the same decagon back. So you got to keep adding 36 here. Oh, I could go 72 degrees. Not a choice. Keep adding 36. Keep adding 36 until we get a choice that's up there. Dividing by the number of sides will only get you the minimum amount of degrees. So we're looking at what, 252 here? Really made you work, huh? Had to go all the way to the end. Another one, we would have just been all the way around. I'm going to come around with a piece of graph paper for every group. All right, because I did provide graph paper for number 8, but you might need it for number 9. All right, and work through these. Work through these problems together because these are not easy. And me standing up here yapping away at you, it's not going to help you. All right, you guys got to experience success and failure on your own. But work in your groups right now. Work in your groups. I'll let you know what the answers are up here. 8's a tough one. The numbers are not going to be pretty, as you're going to see by my answer when I put it up here. You're going to have to use what we used yesterday, writing equations of lines with your properties of quadrilaterals. So here's the answer to number 8. Not pretty. There's number 8. And here comes number 9. Choice 3. Please work with each other. Please work with each other. Call me over if you get stuck. If you guys are good, move on. There's only one exam you're working out of tonight, and that's the January 2024. Okay, so there's numbers 8 and 9. Call me over if you're having problems.